July 1994, astronomers around the world focused their attention on Jupiter because a comet called SL9 was colliding with Jupiter in just 6 days. Jupiter was struck by comet fragments 21 times, creating plumes reaching 3,000 kilometers high. The explosive force of this impact was equivalent to 300 million atomic bombs. The comet fragments traveled at an incredible speed of 60 kilometers per second, with the largest fragment reaching 2 kilometers in diameter. The massive debris clouds from the impact remained visible for months, leaving scars in Jupiter's atmosphere, more prominent than the Great Red Spot. Now I'll walk you through the entire impact process. This comet was actually discovered back in 1993 and drew attention from the moment of discovery. This was because most comets in our solar system exist in the outer regions and orbit around the Sun. Very few comets reach the inner solar system, let alone get captured by Jupiter's gravity. In subsequent analysis, astronomers also discovered this wasn't a single intact comet, but had been torn apart by Jupiter's gravity, looking like a train of space debris from afar. After determining its orbital eccentricity, it became clear this comet would collide in July 1994. This was no longer a secret. To maximize data collection from this impact, astronomers and institutions worldwide collaborated together. This was the only time in human astronomy that everyone mobilized at once. Unfortunately, though, ground-based observatories missed the first impact because the impact site was on Jupiter's far side. Fortunately, several space probes were available. NASA's Galileo Jupiter probe was perfectly positioned for observation, recording first-hand data. Galileo wasn't our only remote assistant. The Ulysses probe, launched in 1990, originally tasked with monitoring the Sun, also turned toward Jupiter for this impact event. Even Voyager 2, then 6.6 billion kilometers away, used its ultraviolet spectrometer to monitor electromagnetic changes at the impact site. In short, every space probe paused its own mission to monitor Jupiter together. Shortly after the first impact, Galileo began transmitting impact images. These images showed a massive fireball rising above Jupiter's outermost atmosphere. This fireball expanded over several minutes, then disappeared after about 10 minutes. After the fireball vanished, a huge dark scar appeared in Jupiter's atmosphere. This scar was larger than Earth. This impact was a valuable opportunity for scientists. They could use it to study Jupiter's deep atmospheric structure. The fireball and scars provided a window. Through this window, scientists could see beneath Jupiter's atmosphere. During the brief observation period, astronomers found large amounts of sulfur and ammonia inside Jupiter. These substances, along with hydrogen, make up Jupiter. At this point, some might ask, since Jupiter contains hydrogen, sulfur, and ammonia, why didn't this impact ignite Jupiter and turn it into a star? This is because Jupiter's mass is too small, while its composition is similar to the Sun. Its mass isn't enough to generate sufficient temperature and pressure to ignite hydrogen fusion. So, neither comet impacts nor other collisions can ignite Jupiter and turn it into a second sun. For Jupiter to become a star, it would need to increase its mass by 80 times. Only then could it reach the stellar mass threshold and become a red dwarf. In summary, the 1994 Comet-Jupiter collision was the only time humans witnessed a cosmic impact firsthand, giving astronomers tremendous insight. It also reminded people that even 4.6 billion years after the solar system's birth, threats from asteroids and comets still exist. Whether it's the 1994 comet striking Jupiter or the asteroid that hit Earth 65 million years ago, these weren't the first and won't be the last.